Hello students, I hope you will be fine today. I solve you the exercise 1.2 from the chapter first. In this video, we study about the fundamental theorem of arithmetic and the relation between numbers and LCM and HCF. So students, I have learnt you about fundamental theorems, LCM and HCF. But we solve the exercise 1.2 completely. In this exercise, the first questions we have express each of the following in the prime factorization. So, students, we take first question and first part. Here, now we have 140. Students, we have 140 and we express in the prime factorization. So, students, we have 140. We have two prime factors. So when the unit place digit 0 or digit by 2, so the whole number is divided by 2. So now we divides by 2 of this number. 2 7 ja 14 to 0, and the percent we write here. We divide again by 2, 2 3 are 6, 1 left, so 10, 2 5 is 10, and we have the unit place is 5, so we can divide by 5, 5 7 is 35 and 7 1 is 7. Now we write the 140 in the form of prime factorization in the prime factors, and we have 2 multiply 2 multiply 5 multiply 7. The next part, second part, we have 156. We can solve and we express in the prime factors as the same question number 1 first part. So we write 156 and 2 7 ja. First we divide 156 by 2 because the unit place is 6, so we can divide by 2. Okay students, so 2 7 ja 14, 1 left, here is 16, 2 8 is 16 by 2. Now we divide 2 by 2, 2 3 is 6 and 2 9 is 18. We can write the percent here. We divide now by 3, 3 1 is 3 and 3 3 is 9, and here in the last we divide by 13, so 13 1 is 13, sorry, and we write 156 as the product of the prime factors, and we can write 2 multiply 3 and multiply 13. Next we have third part as the same, you can solve as the same, and fourth part I solve myself. So question number 1, fourth part, we have 5005. Fourth part, we have 5005 and we have 5005. Now first, when the unit place digit is 5, so we can divide by 5 and we can write below the quotient only. 5 is 5 0 0 1, and we can divide by 11. Here the even place digit and odd place digit difference is 0, otherwise equal by 11, so we can divide by the whole numbers by 11. So students, first we divide by 11. 11 9 are 99, so 1 left and 1 is below put, here is 11, 11 1 is 11. We can divide by 13, 13 7 are 91, and now we can divide by 7, 7 1 is 7, and we can write as the product of the prime factors. So we can write 5 multiply 7 multiply 11 multiply 13. Here is the question number 1 first as the product of its prime factors. You can solve and express the fifth part yourself. If you have any problem, you can ask me about by the method of comments. You can do comments. And so the next question, question number 2, we have the relation between the numbers and HCF and LCM. So the relation I explain you between HCF and LCM and the numbers. We have the relation between numbers and their LCM and HCF. You know about LCM and HCF in the earlier classes. So students, we have the formula, the LCM multiply HCF is equal to product of the numbers. That is the relation, the important relation. So you have to learn by heart, and here we can write this relation LCM multiply HCF and is equal to first number multiply second number. Okay, students. So come to the question. And question number 2, find the LCM and HCF of the following pairs of the integers and verify that LCM multiply HCF is equal to product of the two numbers. We have two numbers 26 and 91. Okay, students. So I start to solve this question. So first we have to learn the formula LCM multiply HCF and product of the numbers. Question number 2. Question number 2. We have first part 26 and 91. So students, you have two numbers 26 and 91. So first we find HCF and LCM. Any method, you can find LCM and HCF many methods, prime factorizations, division methods, Euclid's methods, any other methods. So first I solve and I express these numbers by prime factorization and express these numbers prime factors. Of the form of prime factors, 26 we can write 2 multiply 13 and 91 7 multiply 13. If you do not know about the prime factorization, so we can solve by this rule. 26 is divided by 2, 2 means 2, 2 3 is 6, and now we can divide by 13, 13 means 13, and 91 by divided by 7, and otherwise you can divide by 13. So 7 means 7, 2 left as the remainder, and we below 1 we get 21, and 7 3 is 21. Now we divide 13, 13 means the 13, and we can express these numbers as the product of the prime numbers 26 and 91. Okay, friends, 26 you can expect 2 multiply 13 and 91 is equal to 7 multiply 13. So now HCF, by the definition of HCF, the common factor, the largest, students, which is the common prime factors? Here 13 is the common prime factors, so 13 is the HCF. Students, the product of the common factors is called HCF, highest common factor. Here 13 is the HCF, so LCM. LCM, first we choose and select the common factor 13. After this, which is the prime factors, we can multiply collecting in together, and 13 multiply 2 multiply 7. Here 13 2 is 26 multiply 7, 7 6 is 42, 4 carry, and 7 2 is 14 and 4 18. Here is LCM 182. We have to prove. Now we have to prove, to verify the relation, okay students, the relation LCM multiply HCF equal product of the numbers, Here we have LCM multiply HCF. LCM multiply HCF. Here LCM is 182 multiply 13. 13 2 is 26. 2 carry. 13 8 is 104 and 2 carry 106. We put the unit place and 10 carry. 13 1 is 13 and 10 plus 23. The equation first, because we have to prove and verify the relation. So we put the first relation. Here now product of the numbers, we have 26 and 91. We can multiply 26 multiply 91. We can express as the product of prime. 7 multiply 13. 26 multiply 7 182 and multiply 13. 13 2 is 26. 13 8 is 104 and 2 carry to 106 and 31 13 23. Here by first and second we get LCM multiply HCF is equal to product of the numbers. Verified. So students, we have verified the relation between LCM and HCF, the numbers. So the left questions we can solve as the same. If you have any problem, you can do comment me. Okay students, so come to the next question. Okay students, if you have any problem, I solve your problems. I hope the question number 2, second part and third part you can solve yourself. Question number 3. Find the LCM and the HCF of the following integers by applying the prime factorization method. In this question, we have to find LCM and HCF by the prime factorization method. Students, if we have no common factor to the product of the numbers, so we can take HCF only one. Okay students, so come to the question number 3 and first part. We have come to the question number 3 and first part. Question number 3. The given numbers, first part, 12, 15 and 21, and we have to find LCM and HCF. So first we express these numbers as the product of the prime numbers and prime factorization. 12, 2 multiply 3, so we can express in the form of the product of prime factors. 15, 3 multiply 5, 21, 3 multiply 7. We have the common factor is 3. So HCF is 3 and LCM. First we choose and select the common prime factor, largest common prime factor. So it is here is 3, and we can multiply and we take the product, the remaining factors which is not common in the LCM to find the LCM. So students, we multiply 2 by 2, multiply 5, multiply 7, we get 3 to the 6, 6 to the 12, 12 5 is 60, and 60 multiply 7, we get 70, and 7 6 is 42. Here is the LCM of the three numbers. Next, we take the second part, and we take second part. We have the numbers 17, 23 and 29. Here we have these numbers, these all numbers each of prime numbers. So we can write 17, 1 multiply 17, and 23, 1 multiply 23, and 29, 1 multiply 29, because prime numbers have two factors, only one and itself, only one and itself. So in these numbers we have no prime factor common, so only here is HCF 1. If you have ABC, so HCF of ABC is only 1. Okay students, now we get LCM. So product of the numbers 17, 23 multiply 29, the product of the numbers is LCM. So we can solve this question, all the remaining part of these questions as the same. Okay students, next, now we read and study question number 4. Question number 4, given that HCF 306 and 657 is equal to 9, find LCM 306, 657. So students, first we take question number 4 and question number 4. We have